Hi, I'm Kathy Levinger. In this lesson we're going to graph exponential functions. What we're going to do here is make a table of values for the function below and then sketch its graph. And what you see is f of t equals 1/3 times 3 to the t. At this point you should recognize that the base of the exponential function is 3, so this graph will represent exponential growth. The vertical intercept is 1/3, but we need to have a few other values in order to come up with a graph. So let's pick a few values for t and find some corresponding values for f of t. I'd like to use -1, 0, 1, and at least 2, and we'll see what we can do with those. I know, by the way, that 0 is going to give me a value of 1/3, the vertical intercept. Let's find the others. I want to find f of -1, which is 1/3 times 3 to the -1. You can grab a calculator if you like, but I know that 3 to the -1 is 1/3, and 1/3 times 1/3 is 1/9, and I'll use that in my table. Now I'm going to use the value 1 for t and find 1/3 times 3 to the first power. That's 1/3 times 3, which is 1. And now the value 2 for t is going to be 1/3 times 3 squared, or 1/3 times 9, which is the number 3. Now let's plot these in a coordinate system and come up with a graph for the exponential function. I have a t-axis and an f of t axis. On my t-axis I need -1, 0, 1, and 2. On my in the vertical direction I need to be able to plot a 1/9, a 1/3, 1, and 3. Let's put 1 sort of generously extended up the axis, and we're going to have to estimate 1/9 and 1/3. -1 corresponds to 1/9. That's very close to the t-axis. 0 goes with 1/3, 1 with 1, and 2 with 3. And I can connect those to come up with a graph representing exponential growth of the exponential function. Let's try another example similar to that one. We want to make a table of values for this function, and then we're going to sketch its graph. And this function is f of x equals 2 times 1/5 to the x power. So let's pick some values for x and find corresponding f of x values. I'd like to pick at least -1, and then 0, 1, and 2, and if we need to pick more, if we don't get an idea of what our graph looks like, we'll do so. Right away I know that when x is 0, I'm on the vertical intercept, which for this function is 2, so I'll fill that in the table. And now we'll go to when x is -1, finding f of -1, which is 2 times 1/5 to the -1. 1/5 to the -1, recall, is 5 to the first, and 2 times 5 is 10, so I'll fill that in the table. Now f of 1 is 2 times 1/5 to the first power, or 2 times 1/5, which I'll just consider 2/5 in order to graph. And now using 2, I want to find f of 2, which is 2 times 1/5 squared. Now 1/5 squared is 1/5 times 1/5, or 1/25. 2 times that is 2/25, and I'll fill that in my table. And now I'm ready to plot some points and draw a graph of this function. So here's my coordinate system. I have an f of x axis and an x axis. I need -1, 0, 1, and 2 in the x direction. And then I need to extend up to 10, but be able to somehow distinguish between those. That's going to be hard, but we'll do what we can to estimate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 kind of hits in my arrowhead there. But I'm ready to plot some points. I'll plot the point negative 110, 0, 2, so let me label that as 2. 1 corresponds to 2/5, and 2 to 2/25, which is very close to the x-axis. And now through these points I want to draw a curve, a smooth curve if possible, and I have an approximate graph of the exponential function. Well, let's do one more example, but this time we're going to use a calculator to help and look at an exponential graph on a calculator. So we want to graph g of t equals 3 times 4 to the t. Well, we can't use t's on our calculator, so we're going to translate that to x's. We'll go into y equals, and we'll enter 3 parentheses 4 close parentheses to the x power. Although we could have used a times symbol between the 3 and the 4 to the x. This fits very nicely what you see. Now let's think about a window for this exponential function. What I have on here is not going to be very appropriate. For the x's, I'd like to see some negatives, maybe from negative 3 on to some positives. Maybe we'll go to positive 3 and put our x scale to 1. Those are chosen a little bit arbitrarily, but I do want to put some negative and some positive x's in. As far as y values, I know that this exponential function is not going to have any negative y values, so I'll put 0 as my y min. And if I look back at the exponential function, I can see that the base is 4. It'll be exponential growth, and that's a fairly large base, so it's going to grow fairly rapidly. So let's put a large number in there, like perhaps 50. In which case we might want to make our scale, our tick marks in the y direction 5. And let's see how that graph looks. And if we don't like what we see, well, we'll reset our window. And there's a graph of the exponential function. You can see way down here a vertical intercept. We put our tick marks at 5 and the vertical intercept is 3. You should know that from the equation. Otherwise you see a nice graph of exponential growth. Be aware that the graph doesn't stop here at the left, but the calculator is limited in its physical capabilities of plotting points. In this lesson we've graphed exponential functions. Be sure to work lots of exercises from your textbook for practice.